Assalamu alaikum. Bismillahirrahmanirrahim. Uh, After long days, today we discuss our course title is Service Provider Routing and Switching Specialist JNCIS-SP. There is three modules in this course. One is routing, another one is switching, and last one is MPLS. Okay. So in last class, we discussed hopefully static LSP, this submodule, MPLS, static LSP, and forwarding plan. Okay, so let's go to our slide for this module. In last class, I hope we have covered up to basic configuration, basic static LSP configuration. So today, our class is happened after long days. So let's start from static LSP again and showing you some static LSP configuration and the verification. Okay, so let's start. This is the terminology or key some keyword which is used in MPLS topology or MPLS backbone. Number one is label. That is, it's a you can say it's a numeric number, and basically when um, we communicate from one source to another destination, it's happening based on routing table. Okay, so if we use label instead of routing lookup. So in MPLS backbone, they are using the label value to forwarding packet from one source to another destination. So this is called the label. Okay. Multi-protocol label switching, it's MPLS. That is, you can communicate multiple protocol. You can send layer 2 packet. You can send layer 3 packet over the MPLS backbone. So in that case, the MPLS called the multi-protocol. Okay. Label switch path, you can make separate LSP or label switch path based on your topology. That is called, you can make traffic engineering through the LSP. This is the concept of LSP, label switch path. It's an virtual transport label, ingress and egress router. Ingress means if you consider from journey from one point, like go to our topology, consider this topology, or journey from this router, this BMX1. You can consider this is the P router, provider S router. One customer is connected here, customer side one. This customer one location is site one. This customer another location is this one. This is site two. This is site one, S1, and this is S2, site two. So if I send traffic from this router, so this is the journey point. So this router for this customer, this router will be the ingress router, and this router will be the egress router. Or you can say it's the heading router and this is the tailing router. Okay. So this is the naming convention or naming terminology. Heading and tailing. Ingress means a heading and egress means tail in. Provider is router. Provider is router means uh, this called the customer interface router. Provider is router is you can say this router is directly connected to customer. That means CE, customer is. Provider router is this router is completely in MPLS backbone. This router is not directly connected with a customer. So in our topology, you can say this is the provider A's router, and this is the provider router. All customer is connected with this router. Okay, with this router. So we can say BMX2, BMX3, and BMX4. These are the provider router. Here BMX7, 8, and 9. These are the provider router. And 1, 6, 5, 10. This is the provider A's router. So this is the terminology. Customer edge router. Customer edge router is basically connected with provider edge router, and this is the MPLS operation: push, swap, and pop. Push means inserting level when traffic is coming through IP routing protocol. When inserting in MPLS backbone, that is P router. P router basically insert the level, MPLS level. Okay, and after that, transit router just receiving the incoming level and swapping another level to send to another router. It, that can be egress router or that can be another transit router. Okay, so this the swap operation and the pop operation. Pop operation means just removing the label, removing the MPLS label. So if I consider our topology, one customer is connected with PMX1. PMX1 is the P router, and PMX2 is the provider router. That is swap operation is happened here. PMX3 also the provider router, and also you can say this is transit router. Here swap operation is happen, and BMX4 is the PHP router, penultimate hop popping. This router basically remove the label and sending implicit label to last egress router. And this egress router completely removing the label and sending this packet based on IP routing table. So this is the overall mechanism of MPLS backbone. So these three operations happened in MPLS backbone. There is a different router in MPLS backbone. One is egress router. Egress router basically operate in push operation, and transit router basically handle the swap operation, and the egress router or PSP router basically handle the pop operation. Okay. Penultimate hop popping. This is basically second router. You can say second router from last trailing router or egress router. In our topology, BMX4 is the PHP router. INET.3 table. INET.3 table is basically the MPLS routing table, and MPLS.0 table is basically called the MPLS forwarding table. Okay, so in when you deploy MPLS in your network, you will get two different routing table. One is INET.3 and another is MPLS.0. And INET.3 is basically communicate with INET.0 also. And this is basically happened through BGP. And last one is level forwarding information base, that is LFIP. When you complete your MPLS configuration, they are making MPLS dot zero table, that means forwarding table. Okay, so this table is called the level forwarding information base or level forwarding information table. Okay. So this is the terminology basically. So next move. See here, this is the sample configuration. How to configure static LSP. How to configure static LSP. And this sample configuration is configured in transit router. Configured in transit router. See here, router 2. In our topology, this router is router 2, PMX2. So this is the ingress router. There, this router push the label and sending label to PMX2. PMX2 is the transit router receiving the incoming label and swapping another label to another transit router, that is PMX3. So this is the sample configuration. So how to configure this one? See here, set protocol MPLS. Under MPLS protocol, define the static LSP. You should define the name. This name is user defined and set the operation or role of router. This router is the transit router. Set the incoming label, swap, set the outgoing label, then next one. So if I see our topology, go to PMX2, go to PMX2, PMX2. So edit protocol, MPLS. So see here the static label switching path or static LSP. This is the name. This name is user defined name. I'm targeting our packet will be travel from PMX1 to PMX5. So this PMX2 is the transit router. So this label is the incoming label. How to get this label? So check the PMX1, edit protocol, MPLS. Sure. See here, I push this label in static LSP. This is PMX1 to PMX5. I push the or insert this label, and this same label is receiving from PMX2. So in that case, you can say this label is the incoming label. This label is incoming label and swap assign another label, that is swapping label. That is swapping label. Administrator manually define the swapping label and the incoming label. Completely defined LSP statically. So that's why it's called the static LSP. Okay. So this router role is transit. I mentioned here incoming label. Incoming label is getting from PMX1 and swap, and after swap you can assign the outgoing label. You can assign the outgoing label. So what will be the next stop? My next stop will be the BMX3. So BMX3 interface is 0 by 0 by 1. So go to BMX3, show mass GE-0 by 0 by 1 is constant. See here, the IP is this one, 10 to 3.3. See here, my next stop is this, 10 to 3.3. So this is the way how to create the static LSP when your router is transit. Okay, so when keyword is transit and the operation is swap. This one is the incoming label and this is the outgoing label, and this is the immediate next hop or physically connected next hop. So see here, this is the configuration and this configuration just verification. So I show you here how to configure a static LSP when your router is transit router. So next, how to check the LSP, show MPLS, static LSP, and the role. So run show MPLS, static LSP. You can help static LSP, and your router is transit. See here, show MPLS, static LSP transit. Your LSP name is BMX1 to BMX5. See here, BMX1 to BMX5. And your incoming label is this one. This is the incoming label, and your LSP is up. Your LSP is up. State is up. You can show it in detail. Okay. So status is the next hop, outgoing interface. This is the outgoing label, and this is the incoming label. And when this LSP created, is the time, and no bandwidth reservation is happened here, and the LSP status is up. So after creating the LSP, you can verify your LSP is up or not, or running or not. Okay. Show MPLS static LSP transit detail. Label operation swap, and this is the outgoing label. See here, label operation is swap, and then this is outgoing label. So when I'm swapping label in BMX2, my swapping label is this one, or you can say this is the outgoing label. This outgoing label is receiving BMX3. BMX3 receiving this label as an incoming label, and BMX3 again the label operation will be the swap, and BMX3 set the outgoing label, another outgoing label. Okay, so this process will repeat in BMX3. Same process will repeat in BMX3. So another verification command is run show route table, the MPLS.0 table. MPLS.0 table. In MPLS.0 table, this is the level forwarding table. See here, this is the incoming level, and this is the outgoing level. The operation is swap, and this is the next hop. And this entry is coming from MPLS. MPLS static LSP. MPLS static LSP. Okay, so you can, sorry, MPLS.0. Advertising protocol is label. So label is, this is the incoming label. Say here, single entry. Okay, you can take it details. This is MPLS.0 table. This is the incoming label, and this is coming through MPLS. The operation is swap, and this is the outgoing label. See here, label operation, next hop, and load balance label is one. Stat is active. This is the time metric value. This is happened in AAS. That's why the AS path is horizon I. So you can verify details in any incoming level through the MPLS.0 table. Okay. So in router 3, the configuration is similar. The protocol, MPLS, sure. Say here that this is the name, this is the incoming label. So showing outgoing label, here is incoming label, and setting another outgoing label, and this is the next hop, physically connected next hop, that is BMX3 to BMX4. BMX4 C 0 by 0 by 2. Show as C dash 0 by 0 by 2 plus see here the IP is 10.3.4.4. And the next hop is 10.3 4.4 incoming level, and this is the outgoing level. Static LSP. This is also the transit router. In BMX4, this will be the PSP router. This will be the PSP router because BMX5 is connected with another C router. Consider it. So you can also check. Yeah, sure. MPLS, LSP, transit. Here, no LSP is showing MPLS, LSP. Ingress LSP, egress LSP, transit LSP. No one is up. So you can check. In branch route table ls.0. Yes, getting this one. This is the incoming level and this is the outgoing level. So why not branch MPLS? Oh, static LS. About should be MPLS, static LSP, transit. This is the static LSP coming level in the level LSP status is transit. Level operation swap. This is the incoming level and this is the outgoing level. So go to BMX4. BMX4 will be the PSP router. This router basically pop our MPLS level unit protocol. MPLS. Sure. This router role will be the transit. This is the incoming level, which is coming from BMX3. This level is getting here as an incoming level, and the operation is pop. This level is removed and sending explicit level to BMX5 because I'm considering here BMX5 is the egress router. Okay. Okay. Then so this is the PSP router configuration where pop operation is happened. We already configured this one. So you can verify route table. You can verify route table here. Yeah, sure. Route table. My table is MPLS.0. So MPLS.0. This is the incoming level. The operation is pop. Operation is pop. And here is stack bit equal to 0. Because this level not sending to another MPLS router. Not sending another MPLS router. That's why stack bit is 0. The operation is pop. Okay. So checking end-to-end connectivity. So need to connect one C device with BMX1 and another C device with BMX5. So let's try. So our static LSP configuration is done. Similarly, this is one direction. This is one direction, BMX1 to BMX5. Similarly, we can consider BMX5 to BMX1. So in that case, BMX5 will be the ingress router. This two router is this three router is transit router. BMX2 will be the PSP router and BMX1 will be the uh, egress router. Okay, so let's connect another router with BMX1 and BMX5. Stop this one. Take two router, Juniper, BMX, Pro 2, interface 8. Other setting will be okay. This is site A. Site A. The router is site B. The site B. Site B. So this is basically C router. Customer S router is connected with B router. Provider is okay. So 5, 5. Is connected. 4. Considering 1.1 IP here, uh, I'm taking here 10, 6, 10, 6, 10, 8, 10. This is random, right? Okay. Uh, the block is /24. Okay. So my router is 10, 9, 10. And take here another block 10, 1 to 3, 1 to 3, 0. Start. 1 point out. Yet. The point is and here the LAN IP. LAN IP or loopback IP is for site A 198.51.101. You can take any IP, no issue. Start. So I'll take same. So no 0. My IP 198.51.100. 198.51.100.1/24. The IP is 203.0.113. 2030 203.0.1/28 203. It's good. So considering here, BGP will be the protocol when connecting P to CE. We can consider here ASN, ASN, ASN. Consider here 64512. This is 64512. Or you can consider public case number like uh, 13, 14, 50. Okay, consider this one. Okay, so in our MPLS backbone should need this backbone as number also. That is okay. Just a minute. Okay. So we're connecting um, customer, that is customer CE router, connecting with PE router. Uh, One location is site A, another location is site B. Site A and site B is connected with the PE router. Okay. So considering here the customer ASN number is 131415 and the provider ASN number is 131211. If I sending packet from customer, this is site A, and this is site B, site B the destination, and site A will be the source. Okay. While sending packet through MPLS backbone, see here, trace route showing the packet loss or packet drop when we checking the end-to-end connectivity. Okay. So after configuring, we'll get them, and there is a solution of this, how to recover this or how to resolve this one. So see here, in our topology, we yet not configured the BGP, I think. What? 1, 2, 3. Select, edit. So if I show you enter configuration, see here, just WSP routing protocol is configured here. Basic MPLS and static LSP is configured. And this is the interface configuration. No BGP configuration is happened here. Okay. So see here, trace route shown from site A LAN to site B is the full connectivity. Why are the middle hop not working? Answer, this is a BGP free port. That means No BGP configuration is append in BMX2, BMX3, and BMX4. No BGP is append here. No BGP configuration is. Okay. So let's configure BGP with customer. That is eBGP. Another point is another eBGP. And we need to communicate from BMX1 to BMX5. That will be IBGP. Loopback to loopback. That will be the IBGP. So customer sending this prefix through eBGP, this router sending through IBGP to BMX5. No BGP configuration in BMX2, BMX3, BMX4. And again, customer is communicating through eBGP. So complete our configuration. So we need to configure BGP in P router to C router, PE to CE to communicate with customer. So let's open customer, that is site A, and this is site B. Site A, put, select, edit, show display set. This is default configuration. Load factory default. So on configuration remote. So root 1, 2, 3. CLI. So load factory default. Set system root authentication. Plain password. Root 1, 2, 3. Root 2, 3. Search system host name, that is site B. Site B. Search system time zone. Share. Comment this one. This is basic configuration. Show this set. So configure site A, that is site A. Time zone. Root authentication. Test password. Root 1, 2, 3. Okay, so first configuring the interface C0/0.5, set interface GE 0/0.5 description, that is unit 0 description. Site A is connected, site A, and family inet address IPv4 address is 10.123.1/30. Address 5 site A. This is AMX1. AMX1. That is P router. IP is site A. IP is 2. Good. Checking the connectivity. it's working. Next, another site B. Site B is connected with BMX5. Port. CLI. The interface is CE004 unit 0 description site B and only inet address is 10.123.23.5/30 forward. Show this asset. No BGP configuration here. You can check show this asset. No BGP configuration here. Okay. So similarly in BMX3, no BGP configuration, no BGP configuration. Okay. So in BMX5, we configure the interface port that is site B, and this is in MX5. And the IP address will be the 6. Right. Checking the connectivity. Very big. Okay, next configure BGP, edit protocol, BGP road, BGP ASN 131415. Set drive external, set neighbor. My neighbor will be 2. Description, that is this ASN and stub peer. PRS is 13141. Yep. Not setting import and export by default. BGP receiving all prefixes. Okay. So exit, then wait. Local AS. Set routing options. Autonomous system. Our autonomous system will be 131211. 131211. Router ID. Router ID will be the loopback IP. This one. Okay. That's good. So this is that. Same thing will be in BMX5. The system number, router ID. For BMX5, the loopback IP 1.5. So router ID will be 1.5. The BGP configuration. One 31415 BMX5. Okay. Edit. Rename. Neighbor. This one. Neighbor. Next neighbor will be 6. So neighbor is 6. Basic configuration done. So configure from customer side. First setting the loopback interface, set interface number 0, magnet 0, description, loopback, address is family inet, address 198.51.100.1/24. It's good. And edit protocol, BGP, no, ASN, service provider ASN is 131211. Set type, external, set neighbor. Our neighbor will be this one. Okay, our neighbor will be this one. Restriction. So neighbor ASN. And PRS will be this. We need here export policy, otherwise prefix will not advertised. Export SN. Let me click for. In export policy, we need to allow our prefixes. Set term, from route filter. My prefix is this one. 0/24. Object, then accept. Okay. Set down 1000, then yes. So prefix is accepted. Set routing options AMT autonomous system. Autonomous system will be 131215. And router ID will be loopback IP address. It. Sure, just press it. PCB configuration. This is PCB configuration. Autonomous system. Loopback. This is back. Loopback IP. Side B loopback IP will be 203.0.113.1/24. Loopback address configuration done. Router ID. Router ID will be loopback. And next, basic configuration. Copy this one. So, date. Sure. So, rename. This one. Deeper. Will be fine. First side B. Here, the export policy, identifying section policy statement, out, set term, counted from route filter, or prefix, this prefix, 0, accept, set term, then accept. So prefix allowed in policy, commit, Then checking the BGP status. So show BGP summary, BGP product, getting up. Okay. Checking from site A. Yes, getting BGP up. No prefix active, no prefix active, no prefix received, no prefix accepted, no that. Okay, so no prefix receiving in site A because I'm receiving in C router, P router, PMX1, I'm receiving single prefix. That is advertising from site A. Okay, so we can check and show route receive protocol, BGP, checking from this neighbor. Yes, you're getting this prefix, which is sending customer. So again, check from another P router, that is PMX, that will be 6, and you will get this prefix from customer side. So you yet not make any IBGP session with PMX1 and PMX5. No BGP configured here. No router configured BGP. So if you set this prefix from PMX1 to PMX5, need BGP configuration. Okay, so I configure IBGP from PMX1 to PMX5 direct, not other router. Okay, so let's try configure IBGP in PMX1. Edit protocol BGP group IBGP IPv4 set type will be internal. Set local address will be the loopback IP, this router loopback IP, local IP, this router loopback IP, yes. And my PRS is 131211. Okay, and my neighbor is router 5 loopback IP. Router 5 loopback IP, that is number 5. Loopback to loopback. So my neighbor is 105 and the description is BMX. So my basic IBGP configuration done. Show this site. So copy this one. Paste to PMX file. So ID protocol. So local address. Here local address will be 105 and PRS is okay and the neighbor will be changed. Neighbor 105 to neighbor will be 101. Neighbor will be 101. So local address 5, base number 101, and the neighbor description will be set neighbor 192 description will be AMX1. That's perfect. So commit this one. Check the BGP status. Run show BGP summary. IBGP. IBGP is up. Okay. IBGP is up. No active route. Receiving one prefix. Accepted one prefix, but not active. not agree. So what happened here? Run show route receive protocol BGP from 1.5. No, prefix is hidden. Why? Why prefix is hidden? This prefix is coming but not installed in active routing. What is the reason? The reason behind this branch route. See here, no route is here. So hidden, yes. My no next up is here. Next up is unusable. What is basically happened? Next up need to resolve IPGP don't change next up automatically. So need policy to change the next step. Okay. So need policy. Uh, See here the state is hidden because next stop is unusable. Next stop is unusable because this next stop is indirect, not the direct next. In EBGP, the next stop is direct, but in IBGP, next stop is indirect. So in that case, the route is hidden, not in active route. So need a policy. So need to copy the policy. Just what's this one? Okay, same. So we need policy to resolve this hidden route. Okay. So need a policy. So the policy will be if a route is external route, if route type is external, see here, this route is coming from EBG. EBG. So this is external. Route type is external. So receiving one route through EBGP is sending to IBG. Sending to IBG. While sending to IBGP, they change the next of behavior. Okay. And if route type is internal, that will be only X. No need to change the next. Okay. So this policy will be applied in IBGP group. So create this policy first. So need to configure this policy in my BMX1 and BMX5. BMX1 and BMX5. So copy this one. 1 and 5. 1 and 5. That's good. Perfect. So done. And apply this policy in IBGP group. Edit for group IBGP and set export. Apply the policy. Step 7. Cover this one. Yes. And copy this line from BMX1 to BMX5. Perfect. Okay, then again check run show BGP7. Now it's okay. Getting multiple route here. Getting multiple route here. Check from BMX5. Getting also multiple. This has happened because some route is available in iNetwork 0. That is coming from backend ICP. So ICP route is inserted to IBGP. That's why getting multiple. Okay, let's check our desired route. Run show route receive protocol BGP from customer. I'm getting this route from customer. So run show route. This route is coming from customer. This is customer AS number 131415. So check another P router. This route is coming from this next hub 1.1. Okay, and this the customer is basically this prefix is coming through IBG, coming through IBG. Okay, not the EBG. See here, that is coming from IBG 131211. Local AS and PRAS is same. That is IBGP session. I'm getting this route through IBG. So EBGP, then IBGP. I'm getting this route. Next hop result, and this route is now active in route 10. Similarly, checking from router 5. So run show route receive protocol BGP from customer. I'm getting this route. Checking this route. This route is coming through C0/0/4. That is directly connected customer. That is coming through EBGP. And when I'm checking from BMX1, that will be coming through IBGP. This route is coming from 1.5. Okay, that's good. And see here in route table, see here the label value. See here the label value in BMX1. See the label value, and same label value run show route table MPLS.0. MPLS.0, when I creating static LSP, our incoming label or pushing label in BMX1 is this one. See the route, in BGP route table, this push level. This level is getting from basically the static LSP. Getting from static LSP. So similarly, when you checking in BMX5, that is coming from site A, see here, no label is starting here because we're not creating any static LSP from BMX5 to BMX1. That is return LSP. I am just configuring the forwarding LSP, not configuring the returning LSP. So you can configure here, considering BMX5 is ingress router, configuration will be similar like BMX1, edit protocol, edit MPLS, show this setting. Then show MPLS explicit. This one, BMX3, copy this one, BMX4, and last one, BMX5. Okay, so when considering sending packet to site B to site A, so BMX5 will be the ingress route. For ingress router, our LSP will be, this is the configuration, static LSP, but needs some modification. The name will be BMX5 to 1. 5 to 1. Okay. So 5 to 1. Okay. Then router role is ingress and the pushing level. You can set here you can set here pushing level, that is 54100, and this is 12, that is 54. Set here 5454. Okay, my target is, when I creating a static LSP in BMX5, my target is BMX1. So my target IP is 1.1. And what will be the next stop? My next stop will be the BMX4 Z0/0/3 interface IP address. The IP address is 10454, or you can check from BMX4. The interface is C0/0/3. Show as GE0/0/3, and that is set. See here, the IP, next of IP will be 10454. My IP will be this. So this is the static LSP when I considering BMX5 to BMX1. BMX5 to BMX1. So creating this one, go to BMX5. Run show MPLS static LSP. See here, BMX5 to 1. And you can set here, this is ingress, more specific. My target is this one, 1.1. And the LSP status is up. LSP status is up. When again checking the route, see here, MPLS label is coming in BGP route table. BGP route table. Okay. Similarly, you need to configure in BMX4. In BMX4. BMX4 under MPLS protocol, the operation will be in BMX4, the operation will be transit. So you can copy from 2 and modify this. Modify this. So the naming will be this one, 52521. Transit, you will receive the label. The receiving label is this one. Is the receiving label. And swap label, that is 4 to 3. You can set here 4343. And what will be the next stop? 4 to 3. That means router 3 is 0/0/2 interface IP address. 0/0/2. 0/0/2. Show me 0/0/2. IP address is this. This address will be the next. Okay. 5454, and the swap level is 4343. So copy this one. And this two line will be configured in BMX4. Wait. Run show route level MPLS.G. Getting this one. This is the incoming level and this is the outgoing level. The operation is. And similarly, go to BMX3. In BMX3, you need to modify for BMX3. Operation will be transit. That is okay. You will get incoming level. This will be the incoming level. This will be the incoming level. And BMX3, the operation is transit. This is the incoming level. Next stop will be changed. And the outgoing level is 3 to. 3232. And the next of IP will be router 3, 2. That means 2 interface C0 by 0 by 1 interface IP address. 0 by 0 by 1 IP address. Show as 0 by 0 by 1 is the set. IP address will be this one. So copy this one and change the next one. So this naming will be changed also. AMX 521. 521. Port 3 is incoming level and this is the swapping level. Copy this one and it will be best in BMX3. And finally, in BMX2, pop operation is happened here, like BMX4. Pop operation is happened. So copy this one for BMX2. Incoming level will be this one. This is 521. 521. This is 521. This is incoming level. Operation is pop. 3232. Operation is pop. Need next. So 221. So router 1 interface is 0 by 0 by 0. Show as G0 by 0 by 0 is present. The interface IP is this one. This one will be the next. And this configuration to line will be in VMX2. Will be in VMX2. So this is reverse level mapping for static LSP. So see here, run show route. This is what is customer route. Customer route is, this one is the customer route. This is BGP route. See here, run show route. This route table is here. This route table is BMX5, but not in BMX2, BMX3, BMX4. Because BMX2, 3, 4, not we not configure the BGP. Okay, that's why this route, this is BGP free code. This is BGP free code. No BGP is configured here. Okay. Now checking from site A. So any prefix I'm receiving here. One prefix is coming here. Checking. Show out. For BGP, this is point-to-point IP from another site, but not receiving. I'm in site A. Site A need to receive this prefix. Need to receive this prefix, but it not receive because this ASN, and this ASN is same. So this prefix is advertised through EBGP, again advertised through IBGP, again when sending to same ASN, they are checking it's basically coming from this ASN. This prefix will not advertise towards same ASN. This is the reason. That's why we called BGP is the loop-free protocol. So if we need this one, there is two solution. You can AS override or you can use local AS. You can use local AS. So first, edit protocol, BGP, group, ASN, this one. Need to configure, set neighbor, advertise, set neighbor 10, advertise PRS, advertise PRS. This advertise PRS is basically want to advertise this ASN again. This ASN again. So advertise PRS. This command and PMX5 edit protocol BGP group BGP group ASN this one and set neighbor 10 advertise PRS. Okay, and another configuration we will need here, set edit routing options, show edit routing options, show set local, set auto system loops. Loops means here the scenario is this ASN sending this prefix through eBGP, getting this prefix in ASN, this one, again sending through iBGP, receiving this prefix. When sending through again in eBGP in same AS, they are not received. In that case, I am telling this router, please receive your ASN prefix, your ASN prefix. So in that case, I need to set here the number in AS path, how many numbers will be present. So I set here the set autonomous loops 2. That means if any prefix coming from same ASN, this router will receive those prefixes. This is the main consideration. So loops 2. Cover this one. Cover this one. Run show BGP summon. Get down. Receiving only single prefix. Run show BGP summary. Not receiving. Checking. Well, BGP force restant. Yeah. All these system there will be a number. No stop. Configuration is getting to prefix. Okay. So run show execute 7. Getting. So run show out. See here, this prefix is side B. This is side B. I'm getting this prefix from side A through the BGP. Okay, through the BGP. So this prefix is basically originated in same as, and this is the transit as 13121. Okay. So in my route table, site A, I'm getting same run show route. This prefix coming from site B, I'm checking from site A. I'm getting this prefix. Okay, no issue. So my route transition is okay. Now check. Now I will check end-to-end connectivity. This one, end-to-end connectivity. Want to check this one? Say here, show us hello 0, this plus side bit. This is my target. Wrong ping. This is my target, and this was source. Getting ping. No BGP here. 2, 3, 4. No BGP. Getting ping. Okay. There is one advantage because when you configure the BGP, you need higher model router. Okay. Provider is wrong. So I'm getting ping. So need to send press start. The source target is this, and this is the destination. See here is the IP communication from site A to PMX1. This is CE to PE getting IP, but another next hop PMX1 to PMX2 not resolving the next. Again PMX2 to PMX3 not resolving the next hop. 3 to 4 not. 4 to 5 not. Again we will get 5 to customer side. This basically the scenario. And what will be the solution? We'll work out with this. Say here,
this one, 10455, this one, and this is the last one. Not getting 3 next one. See here, 3 next one. Not getting. Clear? How to check end-to-end connectivity? When your core is BGP free, no BGP configured here. I understand. Just as
Yes.
unverified. It's basically not. It is basically getting in is the validation state. Validation state means you already know some ASN have some prefixes. That means when I origin some prefixes to legal ASN, that will be verified. Verified by any RIR. It can be happening, it can be RE. Okay. So if you origin some prefixes, but this ASN is not legal or this not validated, that means your prefix and ASN is not matching. That is called the validation is illegal or invalid. So when you checking the validation through any RIR, this will be changed. Validation start will be verified. So I'm not connecting with APNIC or others RIR, checking the route. It's my lab. Okay. In that case, the validation is unverified. Clear, Justice? Okay. So how to resolve this one? See here. This is the solution. A trick to see transit hops in a trace route. If you want to see the every hop in trace route, you have to configure set protocol MPLS ISMP tunneling. Configured on all routes in MPLS back. In MPLS back. Transit routers now reply the next. So applying this configuration in BMX1, that means MPLS backbone router, set protocol MPLS ISMP tunneling. Set protocol MPLS ISMP tunneling. Okay, configuring this one, basically all router. Commit this one. Commit this. Process. Okay. No need to configure in customer route. Okay. Only configure your MPLS backbone. Okay. So again check. Again check. Check. Every hop. We're guarding every hop. And the interesting thing is, see here, this is the normal IP routing. See here, this is the normal IP routing. See the second hop. See here, the MPLS level. This is the incoming level. See here, this is the incoming level. and the stack bit is 1 and the TTL value. See the next other incoming label. See here, this of another incoming label and not getting any label value in hop 5. That is VMX4. VMX4 basically remove the label and sending to VMX5. That's why we're not receiving any label here. So same thing you can get from side B. Just reverse your source and destination. Just reverse your source and destination. So for side B, the target will be this one, and the source will be side B loopback. Okay. Same thing will be happened here. This is the incoming level. Number 3, number 4. Not receiving any label in first hop, not receiving any label in 5 and 6. So you can see this is the MPLS bank. Your trace route will show you your sending packet through MPLS bank. Clear? So some provider intentionally hide this one. Intentionally hide this one. If they want, okay. In that case, this configuration, that is ICMP tunneling configuration, this line will be removed there. Okay. So I think end-to-end connectivity is very much clear to you. If you have any question, No question. Okay. See here, how ICMP tunneling work. So normally, the TTL is 0. When TTL is 0, the router sent an ICMP TTL unreachable to the source. When considered cell proper. Instead, it when considering transit router, that is heading router, that is trailing router, one to another. So see here, R3 send the TTL unreachable message to router 5. Then router 5 receives a packet with source IP R3, destination IP site A, C LAN. R5 can then send the packet down the LSP to R1. The traffic trombones slightly and the result is full visibility in your trust. This is basically happen. First is router 5 is sending tag response from router 1, and those all router have loopback IP and point-to-point IP. Those IP are basically connected and that is available in ICP route table. Okay, ICP route table. So in that case, they are making the tunneling from router 1 to router 5 and resolving the internal MPLS backbone next time. Using LSP as a next hop in a static route. What is this? So in a static LSP, you can define. Some just you are making it one static. You are just making one static route. In a static route, normally we define the next. Hop. Instead of next hop, you can assign the static LSP next. So in that case, your static route will resolve the next hop through the MPLS protocol. See the example, set routing options static route, that is the destination. then static LSP router 1, 2, this is the just name, static LSP name, and see the route, and see the route. Okay, so you can check this one like this. So I'm in router one. So saying this my target or destination transfer route. My target is this one. So run show route. This prefix is coming through IBG. Okay, coming through IBG. Okay, then just edit. Sorry, edit protocol MPLS. So this is my static LSP name. Static LSP name. So set routing options, static route. Consider this is the destination. Okay. So you can set here static level next hop, static level next hop. The next hop is your defined name. Okay. So you can also set your preference. So not setting any preference, just commit this one. See the route again. See here, static. The preference is 5. Default is static route preference is 5. This is active, and this is the next one. This next one automatically resolve. Automatically resolve the next one. And this is the MPLS level. So instead, manual next hop or physical next hop, you can use static level, static LSP next hop, static LSP next hop. Okay, if you want, you can do. Okay, so next you are almost ready to begin your first lab. We already complete our lab. So now just question and answer section. Number one question is what operation does the LSP router take to remove and replace the label with the specified label if configured manually? That is basically swap operation. Removing the incoming label and replace the label and sending to another router. This operation is called the swap. So question 2, which table list all incoming labels that the router knows and what action to take on the traffic with the same labels. All incoming label making the MPLS.0 table or a label information is in MPLS.0 table. Which command is used to verify the status of the LSP configured with the swap operation in the incoming label. This is the verification command basically. Show MPLS static LSP transit. If your router is in trace, the command will be show MPLS static LSP ingress. So I think there is lots of section here. So this is the next section, lab environment topology and logical systems. You can configure MPLS in logical system also. Okay. So this will be our next lab, I think. So up to now, any question? Do you have any question or any
আসসালামু
query?
আলাইকুম ভাইয়া। আসসালামু আলাইকুম ভাইয়া।
Walaikum assalam.
হ্যাঁ, আমার এখানে কিছু কোশ্চেন ছিল বলতে এই যে আপনি ওটা করলেন, হ্যাঁ ধরুন ট্রানজিট এস তো আপনার সার্ভিস প্রোভাইডার তো সেটা জানো, ওটাও ট্রানজিটে আসছে। হ্যাঁ,
হ্যাঁ
এখন
হ্যাঁ
ওই যে ট্রানজিট এস এর কথা বললেন এমপিএলএস এর ক্ষেত্রে,
হুম,
এটা তো সার্ভিস প্রোভাইডার, মানে আমার এমপিএলএস ব্যাকবোনের এস, ট্রানজিট এস, রাইট?
হুম।
হ্যালো।
ট্রানজিট ট্রানজিট রাউটারটা হচ্ছে মূলত হচ্ছে আম, এখানে চিন্তা করা হচ্ছে যে এলএসপিটা আমি তৈরি করতেছি, একটা কাস্টমারের রেসপেক্টে আমি একটা এলএসপি তৈরি করতেছি যদি চিন্তা করি। যেমন একটা কাস্টমার হচ্ছে সাইটে, একটা হচ্ছে সাইট বি। এই কাস্টমার, আমি যদি এই পয়েন্টটাকে ইনগ্রেস রাউটার কনসিডার করি, তাহলে এটা হচ্ছে আমার ইনগ্রেস রাউটার, বাকি রাউটার গুলো হচ্ছে ট্রানজিট। হুম। এই এই কাস্টমারের রেসপেক্টে এখন এই কাস্টমার এইখান থেকে কোথায় যাচ্ছে, এইখানে যাচ্ছে। অন্য একটা কাস্টমার এই ভিএমএক্স ওয়ানে কানেক্টেড, কিন্তু তার টার্গেট হচ্ছে বা সে কানেক্টেড হচ্ছে ভিএমএক্স এইটে। তখন ওই কাস্টমারের জন্য এটা ইনগ্রেস, এটা ইগ্রেস। এই কাস্টমারের জন্য ভিএমএক্স ওয়ান হচ্ছে ইনগ্রেস, এটা হচ্ছে ইগ্রেস। ঠিক আছে। এখন এই কাস্টমারের রেসপেক্টে যখন আমি একটা এলএসপি তৈরি করতেছি, তখন এই মধ্যবর্তী রাউটার গুলো হচ্ছে ট্রানজিট রাউটার। এখন যদি এরকম হয় যে ভিএমএক্স ওয়ান এর সাথে একটা কাস্টমার কানেক্ট, ভিএমএক্স টু এর সাথে ওই কাস্টমার আর একটা কানেক্ট, এটা তো আবার ডিরেক্ট, তাই না? তাহলে এটা ইনগ্রেস, এটা ইগ্রেস, মাঝখানে এখানে ট্রানজিটের কোনো ব্যাপার থাকবে না। বুঝা গেছে?
না, আমি 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 বলতে চাচ্ছি আপনার, আমরা কি করি, সাপোজ আমি ওই জিনিসটাই আমি ইয়ে করতেছি, ধরেন সামিট সামিট থেকে যখন আমরা ভিলেন নেই, তো
হুম।
আমাদের রিমোট এস তো আর সামিট জানে না, তাই না?
না,
ওই যে
সামিট
কাস্টমারের রিমোট।
সাইটে, সাইট এ যেটা, এটা সামিট।
আচ্ছা, এটাই সামিট।
হ্যাঁ, মানে সামিটের সাথে তো আর আমি এমপিএলএস করবো না, এমপিএলএস তো আমার ওন ব্যাক বলে থাকে।
না, ওরা যে আমাদেরকে ভিলেন গুলো প্রোভাইড করবে, তো ওরা এমপিএলএস হতে করে, তাই না?
হ্যাঁ,
সামিট সামিট যখন আমাদেরকে ভিলেন দেয়, আমরা যখন সামিট ধরেন একটা ক্লায়েন্ট আপ করার সময় ভিলেন নেই, ওরা তো
হ্যাঁ,
ওদের নেটওয়ার্কে এমপিএলএস করেই করে, তখন তখন সেক্ষেত্রে কিভাবে
হ্যাঁ,
হয়?
হ্যাঁ, তার ব্যাকবোন এমপিএলএস যখন আমাকে দিচ্ছে, সে হচ্ছে নর্মাল দিচ্ছে।
তাহলে কি ওই সাইট রাউটারটার পরে কি সে একটা আবার সুইচ বসায়?
না, সুইচ বসানো তো ম্যান্ডেটরি না, আমি রাউটার থেকেই তো এল টু সার্কিট দিতে পারি। রাউটার থেকে আমি এল টু সার্কিটও দিতে পারি, এল থ্রি সার্কিটও দিতে পারি। এখানে তো
আহ,
সুইচের প্রয়োজন নেই।
এখানে ভাইয়া
ডিরেক্ট।
পয়েন্ট টু পয়েন্ট গুলো যে প্রত্যেকটা রাউটারে বসাইছেন, ধরেন 10.1.2.1/24 সাবনেট, এগুলো তো /30 সাবনেট দিয়েও করলে অসুবিধা ছিল না, না?
কোনো অসুবিধা নেই, আমি স্ল্যাশ
আচ্ছা।
থার্টি ব্যবহার করতে পারি, /31ও ব্যবহার করতে পারি। এখানে ওরা বেসিক্যালি বইয়ে এইভাবে করছে, ওই জন্য আমি এইভাবেই করছি,
আমার
যাতে
আমার
স্লাইডের সাথে ম্যাচ করে
আমার
দেখানো যায়।
মাঝখানে 3টা রাউটার তো আমার ট্রানজিট, তাই না?
হুম,
ওই কারণে
হুম।
ওগুলো তো আপনার বিজিবি পেয়ারে আপনার পার্টিসিপেট করে নাই, বিজিবি তো।
প্রয়োজন নাই, আমি চাইলে করতে পারি, আবার নাও করতে পারি।
কিন্তু
কারণ
আমি এখন
বিজেপি
চাচ্ছি।
পি করার অর্থটা হচ্ছে কি,
হুম।
বিজেপি করলে তো বিজেপির একটা লোড থাকে না।
হুম।
মানে যখন কাস্টমারের প্রিফিক্স সে রিসিভ করবে, তখন অনেক কাস্টমার হইলে অনেক রাউট টেবিল অনেক বড় হবে। এখন আমার যদি দেখা যাচ্ছে যে মাঝখানে রাউটার গুলোতে আসলে কোনো কাস্টমার কানেক্ট নাই, তো এগুলোতে বেশি লোড দেওয়ার তো দরকার নেই। তো সেই ক্ষেত্রে আমি এগুলোকে বিজিবি ফ্রি করতে পারি।
এখন ধরেন আমি চাচ্ছি, ধরেন ট্রানজিট রাউটার আমার, ধরেন VMX3, এটা তো আর
হুম,
পপ না, এটা তো আমার সোয়াপ করে দিচ্ছে, তাই না?
হুম, হুম,
আমি চাচ্ছি এখান থেকে আরেকটা কাস্টমার আমি আপ করব, সেক্ষেত্রে আমার
হুম,
এটা তো অলরেডি আছে সোয়াপে, কিন্তু আমার তো
হুম।
দরকার পপ, তাহলে সেক্ষেত্রে আমি কিভাবে আপ করতে পারি?
সেটা তো স্পেসিফিক যে এলএসপি হবে না, ওটা তো এলএসপির উপরে, যখন আমরা ওই কাস্টমারের রেসপেক্টে এলএসপি কনসিডার করবো আর কি। হ্যাঁ, তখন ওই কাস্টমারের রেসপেক্টে এলএসপিটা ডিফারেন্ট হবে, যখন সে কানেক্ট হবে যে রাউটারে, ওইটা তখন পি রাউটার হিসেবে কাজ করবে। যেখানে ড্রপ হবে সেটা হচ্ছে অ্যানাদার পি রাউটার হিসেবে কাজ করবে।
কিন্তু VMX4 এর জন্য তো এটা আবার সোয়াপ রাউটার।
হ্যাঁ, তখন ওই কাস্টমারের জন্য ওইটা কিন্তু আবার সোয়াপ না। প্রতিটা কাস্টমার মানে আমি চিন্তা করতে পারি আলাদা আলাদা এলএসপি, আমি তো এখানে মাল্টিপল এলএসপি তৈরি করতে পারি। এক কাস্টমারের জন্য একটা রাউটার হতে পারে রোল প্লে করবে ট্রানজিট, আর একটা কাস্টমারের ক্ষেত্রে ওই রাউটারই আবার রোল প্লে করবে হচ্ছে ইগ্রেস অথবা ইংরেস। নো ইস্যু। বোঝা গেছে? আর
বুঝতে
এটা তো জাস্ট স্ট্যাটিক এলএসপি দেখানো হচ্ছে জাস্ট বোঝানোর জন্য যে এমপিএলএস আসলে কিভাবে অপারেট করে। বাট প্র্যাকটিক্যালি আমরা যখন করি তখন তো আসলে স্ট্যাটিক এলএসপি ব্যবহার করা হয় না, তখন ব্যবহার করা হয় ডাইনামিক এলএসপি। তখন এটা রাউটার অটোমেটিক্যালি এটা সেট করে নেয়। এই মানে লেভেল নিয়ে এত মাথা ঘামানোর প্রয়োজন নাই, লেভেল রাউটার নিজেই সেট করে নেয়।
না,
বোঝা
আমি তো
গেছে?
আবার ধরেন প্রত্যেকটা ইয়েতে তো আবার স্ট্যাটিক ওয়েতে আমি আবার লেভেল গুলা করছি,
হুম।
পাঠাইছি।
স্ট্যাটিক করে তো আর কেউ চালায় না।
আচ্ছা, এটা আমরা ল্যাব পারপাসে মানে আমরা তো আপনার এই যেটা স্ট্যাটিক করে করছে এটা তো আবার ধরেন বিজিবি থ্রোতেও করা যায় লেভেলটা।
না, এলএসপির জন্য আলাদা প্রোটোকল আছে, এলডিপি, আরএসবিপি বা সেগমেন্ট রাউটিং, ওগুলো সামনে আছে আর কি।
আর
এই যে
কনফিউশন
পরে
এখনো
হচ্ছে
মাথায় ঘুরতেছে।
আরএসবিপি।
বলতে আমি ওই সামিটের সাথে চিন্তা করতে গেলে মানে অনেক কিছু মাথায় ঘুরতেছে। বিষয়টা এখনো পুরোপুরি ক্লিয়ার করতে পারিনি আমি। আমি বুঝাতে
হুম।
চাচ্ছিলাম ধরেন এই যে ধরেন আমরা পয়েন্ট টু পয়েন্ট, ধরেন আমরা
হুম।
এন্টিটিএন সামিট তো এন্টিটিএন, ও তো আপনার কি করে আমাদেরকে এমপিএলএস এর থ্রুতে আমরা লাস্ট মাইলে যেভাবে মাঝখানে তো ওরা এমপিএলএস ইউজ করছে। এই যে আমার
হ্যাঁ।
এখানে যখন আমি ট্রেস করছি পয়েন্ট টু পয়েন্ট মাঝখানে তিনটা হপ আসছে, ঠিক আছে, কিন্তু
হুম।
আমি যখন এন্টিটিএনের ক্লায়েন্ট এন্টিটিএনের একটা ক্লায়েন্ট আপ হইলো ওরও যদি পয়েন্ট টু পয়েন্ট আইপিটাকে যদি আমি যদি ট্রেস করি মাঝখানের হপ গুলো তো আর সেক্ষেত্রে দেখায় না, কিন্তু এখানে আবার
মাঝখানে
দেখাচ্ছে।
হব কেন দেখাবে? সে তো এল টু সার্কিট দিচ্ছে। এল টু সার্কিট হলে মাঝখানে হব আবার কই থেকে আসবে? এটা তো সেই এল টু সার্ভিস দিচ্ছে, এমপিএলএস এর উপর দিয়ে এল টু সার্ভিস দিচ্ছে। এল টু দিলে তো আর এখানে মাঝখানে হব থাকবে না।
বুঝতে পারছি, আমরা এখানে
সেটা
করছি
তো।
মানে এল3 না, মানে আমরা তো।
হ্যাঁ, এটা এল3। আমরা তো এমপিএলএস, আমরা তো এখনো এই ভিপিএন এর কোনো সার্ভিসে যাই নাই। এটা মানে জাস্ট নর্মাল।
বুঝতে পারছি।
আমরা এখনো ভিপিএন এর ভিতরে ঢুকি নাই। এল3 ভিপিএন বা এল2 ভিপিএন এগুলোর ভিতরে ঢুকি নাই। আমরা ইন জেনারেল চেক করতেছি।
আমার রাউটিং এর ফাংশন হলে এই এই প্রসিডিওরে হবে আর কি না,
হুম।
সুইচিং
এখনো আমরা
রিলেটেড।
যেটা আছে সেটা হচ্ছে বেসিক।
আচ্ছা, বুঝতে পেরেছি।
ঠিক আছে।
হুম। আবার নিচের গুলা কেন ভাই, ওই যে নিচের গুলা কতগুলো টানছেন রাউটার, এগুলো এগুলা কি করলো?
এটা হয়তো বা আর একটা এক্সাম্পল দেওয়ার জন্য করছে ওরা। মানে বেসিক্যালি ওখানে বইয়ে যে টপোলজি দেওয়া আছে ওই টপোলজি এখানে আমি ড্র করছি। হয়তো বা এখান থেকে আর একটা এক্সাম্পল দেখাবে।
আপনি কি ওই এতে ওই ভিএমএক্স 1 আর ভিএমএক্স 5 এ ওই যেহেতু আমার দুইটাই আছে, একটা ট্রানজিট এস আর একটা হচ্ছে গিয়ে 13 মানে ক্লায়েন্ট এস যেহেতু আমার দুইটাই সেম, ওই যে আমার ইয়েটা আসছে না, সেক্ষেত্রে আপনাকে আবার নতুন করে ইয়াতে কি ওই এসটা কি দেখাইছেন নাকি এটা কি একটা করছিলেন যেন ওটা?
বুঝি না।
ওই যে ভিএমএক্স 1 আর ভিএমএক্স 5 এটা দুইটা অ্যাস আমার যে প্রিফিক্স আসতেছিল না, লুপ প্যাকেট প্রিফিক্সটা যে পাচ্ছিলাম না বিজিবি সামারিতে,
হ্যাঁ, হ্যাঁ।
এটা কি করছিলেন
ওটার
একটু
জন্য ওই যে
আমাকে
এক্সট্রা
দেখান।
একটা কমান্ড দেওয়া লাগছে। সেটা হচ্ছে যে বিএমএক্স 1 এবং বিএমএক্স 5-এ এক্সট্রা কমান্ড যেটা দেওয়া লাগে সেটা হচ্ছে যে বিজিপি পিআর, কাস্টমারের সাথে যে বিজিপি পিআর, এটাতে যে অ্যাডভার্টাইজ পিআরএস এটা বলা লাগে। আর কাস্টমার রাউটারে গিয়ে ওই লোকাল এস দেওয়া লাগে, মানে লুপস।
বুঝতে পারছি, মানে আমার বিজিবি তো আপনার একটা এস এর বেশি আপনার দিয়া করবে না।
হ্যাঁ, হ্যাঁ। যে ও তখন দেখবে যে এস যদি আমার, আমি যখন কোনো প্রিফিক্স পাবো ওই প্রিফিক্সে যদি আমার নিজের এসই যদি থাকে তাহলে আমি এটা রিসিভ করবো। এখানে লুপস টু মানে হচ্ছে যে 2 পর্যন্ত যদি থাকে, মানে এই যখন অ্যাডভার্টাইজ করবে প্রিফিক্সটা সে প্রিপেন্ড করতে পারে না, প্রিপেন্ড করলে তো ওর এস দুইবার দেখাবে,
হুম,
দুইবারও যদি দেখায় তাও রিসিভ করবে। কিন্তু দুইবারের বেশি যদি এস পাতে এসটা থাকে ও তখন আবার রিসিভ করবে। এটার মানে হচ্ছে এটা, মানে এটা হচ্ছে এস পাথ লেন্থ, এস এর এস পাথ লেন্থ।
বুঝতে পারছি।
বুঝা গেছে?
Thank you, ভাই।
প্র্যাকটিস করতে হবে আর কি, হ্যাঁ।
হ্যাঁ।
ওকে
মানে না, আমি ওটার সাথে ইয়ে করতেছি তো, মানে আমি ধরেন ওই যে আমি ওটাই বলতেছি, সামিটকে আমরা ভিলেন দেই না, এখানে অ্যাস দেই না, সামিট আমাদের অ্যাস কিভাবে জানবো, এখানে কাস্টমার অ্যাস, আবার সামিটের অ্যাস না ধরলাম ট্রানজিট অ্যাস। কিন্তু এখন তো ওটা তো ইয়ে করলেন যে ওই রাউটারটা আসলে ওদেরই থাকবে আর কি, মানে সার্ভিস প্রোভাইডার।
ওকে, ঠিক আছে তাহলে দেখা।
ঠিক আছে ভাই, আসসালামু আলাইকুম।
হ্যাঁ, হচ্ছে এমপিএলএস এর হচ্ছে একবারে ডিটেলসটা হচ্ছে পাওয়া যাবে জেএনসি আইপি তে। আইপি তে ওখানে এমপিএলএস L2 ভিপিএন আলাদা মানে মডিউলই আছে, L3 ভিপিএন এর আলাদা মডিউল আছে। এখানে ইন জেনারেল একটা কনসেপ্ট গো থ্রু করা হয়েছে আর কি।
ভাই ওই জিনিসটা একটু দেখেন, মানে ওই যে ভিলেন, যে এন্টিটি যেভাবে ভিলেন
হ্যাঁ,
ক্রিয়েট করা।
এখানে সিলেবাসে যা আছে তাই।
আচ্ছা
ওকে, ঠিক আছে।
আচ্ছা, ঠিক আছে ভাই, আসসালামু আলাইকুম।